Yeah, so we looked at prefix and postfix. We started off with y equals y plus 1, and then we did y plus equal to, and also we went along the lines of y plus plus, which was the postfix, and then we went along the lines of plus plus y, and also eventually we did some decrements as well. And we try to show that when it's the y plus plus, of course, it will just basically update after the statement, right? And then when it's the prefix, which is plus plus before, it will update before the statement is fully executed. So just before we left, I believe we started looking at the while statement. So there's the point where we ended, and is less than 100, then we say try a bigger number. And I gave you a task where I said, get the user to input the number, right? I can just simply do two steps where I do cout and I say enter a number. And I'll do cin, so I'll do cin, take the number, and I can do a comma there. So when we start, let me type, you finally enter the number, you finally, let me use less than or equal to here. You know, it's just the same code we wrote last time. I'm just making some slight changes to it, okay? Yeah, then 100. We study execution. We are currently on line 16, which says enter a number. Let's try 100, which is, of course, not bigger than 100. And then it says try a bigger number, and then we try maybe 1,000. And then you finally enter the number bigger than 100, right? So let's say try a bigger number, and I still don't like that. So I'll just put this, and I will say, yeah, enter a number for another prompt. Let me see, this normally should work, but if it complains, then yeah. Let's try smaller number, 99. And I'll try 33, 4004, and it works. So the \8, did you hear the sound on my side?
Yes.
Yes.
Yeah, the \8 is for the sound. I can just make more to see if, as long as it doesn't complain. It's like the prompt, so we enter 1, and it keeps asking again. Until we go for something bigger. Then, so what is happening, right? What is happening is, so it checks the condition in terms of the number that's been put in. Before, we didn't prompt for anything, so it printed so many times, but now it will prompt try a bigger number, and then we'll say enter a number, then we wait for the user to enter a number, and we'll just check the condition again and again and again. And when the conditions are met, and of course, if or are not met, then we'll go skip the while loop. That's what we've done so far, is just added a string. So if you see, we've added a string, a string library, so we can make use of strings, and we've created a string called password, and we say enter password, and we said if the password is not Michael is cool, then it should say what is the password. So keep asking for the password, and once it does so, you just say we can add something like access granted. I'm going to add access granted here. So I'll put access granted there, and I'll use \n to Go to the next line. Or go to a few lines below it. Then the previous part that we have explained will continue. Copy and paste work for us. So that works. But I still want to see how it behaves when I put in the wrong password. Okay, that's right. So it was interpreting the space, each space as a separate input for the while. That's why it didn't work. Now, Michael is cool. We can play around it a bit, so that works. We can play around it a bit. So like we said earlier, in here we can have, let's put it this way. We can have string access password equals Michael is cool. I mean, whoever made that suggestion, what was the name? It was a different question, but it gave us an idea to do this. We can simply then we say, if the password they have entered, if the password they have entered is not equal to the access password, then it should give us this response. Let's run it and see. Any number? And let's go for something else. And let's go for the right password. Try that out. And it works. Access granted, enter a number, and again, different numbers. And it says, okay, it works. Right, so I'm going to give you the chance to write the code from your side and then test it as well. Use your own password and other things. Was that a question for me?
Yes, Professor. How do we say it wrong password after we enter a wrong password?
Sorry? Here, in the while loop, you can just simply see out wrong password if you want.
Okay, okay, thank you.
Yeah? You make use of the see out options, which we've played with for quite a lot of times. Let me type local password and print that out. And when we call the function, we want to pass this access password to it. So even though that is a local variable, it's still going to take it now because it's taking that local variable, passing it, and then using it internally. Know where the error was because we passed an argument to it, but we didn't give it in the declaration. So let's declare it here and then run it again. Hopefully no errors this time. Yep, no errors. So basically it's that one work because we passed the local variable to a function that it can make access to it, and then we can actually make use of it from the function. But I still like the idea of having it as a global variable. So at this page, we let them input a number and then we check whether the number is less than 100 or is greater than 100. We want to make sure that the number they enter is bigger than 50, is between 50 and 1,000 or 200. Yeah, so we'll just say, while the number is less than 50, so between 50 or the number is greater than what, 500? Yeah, that makes sense. Greater than.
Type this or beside the 50.
Sorry?
This line beside 2 lines beside the 50.
How do you get it?
Yeah. No, I mean, how do you type them in that keyboard?
It depends on the keyboard, but mostly, next to the enter keyboard, you've got a backslash. So you press the shift and the backslash. Did it work?
No.
So I'm changing it to, let me comment out what we had before. So when I send the code, you will see. Instead of try bigger number, I'll just say try again. And then I'll say enter a number between 1,550 and 1,500. Okay, so let's try, see if it works. So Michael is going to enter password. Why do we show them the password first? Well, too late. Let's go with that. Access granted, enter a number, I'll enter 2. Okay, enter a number between, I'll enter 1,000. Beeps again, I'll enter 60. Then it works. Yeah, give it a go. I look to do accounting. So something like, let's say we have 2 numbers, right? And we have a smaller number and a bigger number, right? I think in the past we wrote a code to ask the user to input a small number and a bigger number. You can do this in here. So we just say, let's make use of constant variables. We just say we have an integer called small number or minimum number. And we will assign that to.
Let's start from 0.
Let's start from 0. Thank you. So we assign it to 0, and then we have an integer called big number, right? And then we can assign it to what? 100? Before that, I want to show something. If I select run, it runs all right for us without an error. But if I say, let's say big later, we update big number to maybe 500. We don't expect it to give us an error because we've been updating numbers or variables after they have been declared all along. Now, if we define the big number as const, what that means is that later on, we don't want any function to change the variables. We don't want you to change the size. So we just say run, and then it gives us an error because we try to change the value of const at this point when we shouldn't be changing that. So I'm going to move these variable declarations to make them global. So I'll make them global variables on here. So we can declare a function that will use it. So we have a small, let's make a constant as well. We have a smaller number and a bigger number, and we want to have a function. Let me move all my functions to the same place. So at least it's a lot easier to read the code. I normally leave spaces, but because we want it to fit. So we have a function, we want to add a function, and this function returns an integer, and the function will be called count, and it will take the 2 integers as variables. So I'll say int small and maybe int big. And we want to give the actual function definition at the bottom here. So we can go after this one, and we have the function, and we want to define what it does. We've only declared it so far. So in terms of what the function does, we just want to say while, because the smaller number will go to the small and the big will go to the big. So we want to say while small is less than or equal to the big number, we want to run something, right? So what do we want to run in this code? We just want to say,
Increase it by 1.
sorry, increase by 1, wonderful. So we want to print out first, let's print out the small number first, but that's exactly what we want to do, what you just mentioned. So we want to print out both of them. And we have already introduced in the test, we've already introduced \a. What did it do for those who did it, who wrote the code?
It makes the computer produce the sound, a beep sound.
It produce sound. What does \n do?
That's a new line.
New line.
A new line, yeah.
So we will introduce another one in a second, right? We can do the plus at some point, but at the same time, we want to print out like something like small, the square of small, so small times small, for example. Then we will take the advice that came earlier on board in a second. Then we want to end line. But then here is the, here's the bit about the advice, which was small plus plus, right? Which is what? A post, yep, wonderful. Good, so in here, let me run this, let's call this in the code. We want it to be the first function we call. And because, remember, it returns an integer. So first of all, because it takes this one, actually because we do a cout in there, we don't have to return an integer because we are not returning any integer. Let me get rid of that. Let me make this void. And let me make, where is it? Let's make a void too, because we are not returning any data before we're going to do a count and return something. But the plus plus takes care of the count for us, which is small equals small plus 1 until it becomes close to the big O number. And then we come here and we have counts, and it takes 2 parameters, right? The first parameter is the big small number. Let's make the small the first parameter. And again, you can, of course, ask the user to input these variables, especially if you don't, then in that case, you don't make it constant, right? Oh, semicolon. Yeah, so it's sort of printed everything all together, not in a way that is very clean, but it started off from 0, 0, 1, 1, 2, 2, and other things. So it's printed, it's not really that clean. So let's clean it up with another one, which was, well, it made the sound. We don't want to make the sound right now. We want to, well, we can make the sound, but again, we can put a tab, which is \t on there, and we run the code again. So now it's a lot cleaner. So we have 0, 0, 0, 1, 1, and other things. So you can make sure that you print it out. Let me make, I think the tab is too wide, right? And I'm going to see out something before the tab, and we will print 2 things. Small number, and then we'll just print out also squared. And if you want, or you're anything like me, you probably want to do this as well. So in the process, we've also learned about functions as well. And I know we started with functions from day 1. And we just dig deeper into things as we go. So it will look like, so we've used the while statement to count and everything. But if you see this part, if I go a bit down and you see this part, what do? First, we ask the user to enter the password. Then we check the password, and then we ask them to enter the password again. Similarly, here we ask them to enter a number. Then we check the number. Then we ask them to enter it again. So let me just save this code here right now. Then we can make some changes to the code as well. And I'll call that well. So we notice that in here, if we go back to the first one, actually what we want to do is that we want to run the task at least once before we do a check. So we want to say, enter the password before we check to see whether they've entered the right password. Otherwise, we want to keep asking them. Otherwise, if it's the wrong password, it's going to skip, right? So let's try something that works in a similar way as a while loop. So I can actually comment this one out. Comment that out. Then I say, do, we want to do the statement once, do. And in the do, open, close. So it's a do while loop. So we do it once at least, then we say while, then the condition, we check the condition. So while password is not equal to access password, it will do what's in the, it will go back to do what's in there. So what we want to do is, what is the password? And then we see in password. We notice it's a lot less code in this particular case because it does the job in a much better way. So we try it once and we say, what is the password? See in password, and then it will just say access. So password. So I run it. No errors. What is the password? It's going to do it at least once, right? Because it's done it before checking for us. Let me put wrong password. Then it comes back again to say, now the while is working. Check the while first to say access granted. Then in this case, once. So let's say, how do we tell the difference between the do while? Actually, let's fix this one as well. We're going to fix this code to enter a number. So let's comment. And again, we'll use the do while. So we say int number, do, open, close, and then while. So we move our while loop in there. End that statement, and then we say enter a number, because then we've not tried at all. So we're just going to say enter a number. Yeah. So you just keep saying enter the number between that, see if it works. And then if we get a right password. Then say enter a number. So he's done it once, enter another number, then that, and then that until right number. Now let's try. So it's sort of, in this case, it serves the purpose. We want to see slight difference between the difference between the do while and the while loop, right? So let's say we have, we say, see out. We want to declare an integer called x, int x. And we say, see out, enter a number, right? We can end line there. And we want to say, while the number x is less than 20, count. I know I've not accepted the number yet. So we just say x equals, let's do x plus equals no, yes, to s plus plus, that works, s plus plus. And we will see out the value of x. So we just say x equals x, and we can end line. So let's see in x, and end this here. So what we're saying is we take a number and then we check to see if the number is less than 20, then we do the addition, right? And we print it out. Right. So let's see what happened at the top. Oh, do I call it before the function? We don't want the function. Let's move this to the top just before the function so we can just focus on that part. Yeah, enter a number, and I'll enter maybe I'll enter 2. Then it does the counting for me. So let's see what happened. It say x is equal to 3 because it's done s plus plus s equal to 4 all the way to 20 because what? X is less than 20. Does that make sense?
Yes.
Let's see what happens if,
Sir,
yeah?
but we didn't use less than or equal to.
Yeah, so we say less than 20. So when it reaches 19, what at this point, the value of x is 19, s plus plus 19 plus 1 is 20. So just print out 20.
Oh, okay, sir.
The same way that the first instance, x is equal to 2, s plus plus is 3. So the first thing it printed out was 3. Yeah?
Yes, I think so.
If that is confusing, let's do it this way. Let's remove the new line. Stop. And I can remove the new line and put a prompt. Yeah. So if I run it, you see, let's put the 2 again. 2, and then you realize that it's printed it 3 all the way to 20. Does that make sense now?
Yes.
We want to test right now is what happens if we put a number that is 20 or above. So let's run it again, stop and then run. Then, oh dear. Is it stuck now? Good. And then we provide 33, for example. When we provide 33, you notice that it skipped this altogether. It never ran. It went back to the second function. Yeah?
Yes.
So, or to make the code a lot cleaner, let's add y. So we say enter 2 numbers. And we'll take x and y, right? So we take the x and then we take the y in there. So we take, first of all, for x, we'll do that and we'll write exactly the same code at the bottom, but we make it y. So we're gonna have, instead of all this, we move the while loop. Whoa. Come back. Stay there. Okay, Control Z. We just move the while loop to the end and we use the do. So to make it a do while. And the do, we want to go with y value and we say y equals just replace X, as long as it makes sense to you, and then 20. So in both cases for X, when X is less than 20, they should work, and then Y is, the condition is also Y less than 20. So let's try. Oh, semicolon. Let's run it again. We press 2, and then 2, and then we press enter. So the first instance is worked out what X, then it's worked out Y. It's not that clean. Let's make it cleaner so we can all see it properly. I'll just put this. Okay. Run again. Why am I forgetting semicolons today? So run it to make sense. Then we go up. So we've got the X values, then the Y values also showing, right? Right? Right. Yeah. Now I want to try to see the difference between how the do while and the while operates, right? So I start again, and then I'll put number bigger than 20 for X, and I'll put a number bigger than 20 for Y. So 50-50. So we see which one of them runs at least one. So the Y run at least one. Does that make sense? So even though the X didn't run, these are the numbers we entered. Skip the X altogether. The Y will run first before it checks the number is less than 20. I shouldn't have run this. So in some cases, it's not the best option. The do while is not the best option. But in other cases, something like when you are using a password, for example, where you want to at least give the user at least a chance to enter the password, then the do while works is probably the better option than the while loop.